Hello everyone, welcome to the video on Mathematics 10. In this video, we're going to talk about the domain and range. Before we start, you should know how to sketch the graph of the linear equation. Also, you should be able to identify what the independent variables and the dependent variables are, depending on the situation. After this video, you should be able to determine the domain and range of a relation and explain the difference between the continuous and discrete data. Let's try the first example question. The amount of gas in a car during a 4-hour ride is modeled using a linear relation. So you can imagine that the gas tank is going down over time. Are the variables continuous or discrete? Explain. Well, first let's talk about the idea of continuous and discrete data. Continuous data is when you have a continuous amount, not instead of chopped down numbers. So if your numbers are going like 1, 2, 3, 4, 5, that's what we call a discrete data. Continuous data is where you have more continuous with no stops in between. Or in other words, we like to say the continuous data is where something that you measure, whereas the discrete data is something that you count. For example, the number of humans in a classroom, well, we count the number of heads. So that's discrete data. And continuous data is things like distance or time, where we measure the time or distance. So that's continuous. Well, what about the volume? What about the amount of gas? Well, I think we don't count the amount of gas. We measure the amount of gas. So I think gas is the continuous data. Well, the other variable that we have is the time. Right? The time is also something that we measure. So the time is also the continuous data. Also worth noting the difference between the independent variable and the dependent variable here. The independent variable is usually something that you go and switch. And the dependent variable is something that is switched because of it. Well, in this case, in my opinion, I think time is something that will change, that we change. So we can decide, okay, let's ride for 2 hours, let's ride for 3 hours. And the amount of gas will be the dependent variable, is something that changes because of the time. Right? We can't really control the amount of gas that we have. We can only control the amount of time that we drive for. So in this case, the gas will be the dependent variable. And the time will be the independent variable. So once again, continuous data is where something that you measure, and discrete data is something that you count. Let's look at the next question. Find the domain and range of the nonlinear relation shown in the graph below. So let's look at this graph, and let's think about the word domain and range. Domain is the set of all values possible for the independent variable, or x. Whereas a range is a set of all values that are possible for the y value, or the dependent variable. So first, in order to find the domain, we need to look at where, for what value of x, does this graph not exist? Well, let's look at it. Can I have a value of, can the graph exist at this point when x equals 2? Well, it does. What about x equals 7? Well, it does. What about x equals 100? Well, we can assume that the graph goes infinitely long, and yes, x equals 100 will work. In fact, in this graph, there's no limit on the domain. There's no limit on the value of x that we can have. So we can say that domain is x is an element of all real numbers. We'll annotate that in a second. It means that x can take any values possible. Let's look at the range as well. The range, we're looking for the y value. So we're looking at, hey, what value of y can I have? Well, obviously we can have the y values all the way here, but interesting thing happens at 4, -2. The graph bounces back up. This means that the graph does not exist below -2. So the smallest value that is possible for y is -2. So I think the range can be written as y is greater than or equal to -2. So domain and range, we're looking for the set of possible values of x and y, and we write it as these using these notations. Let's annotate them. So XER, this weird symbol means is x is an element of. So that phrase is this weird symbol that looks like E, and also the all real numbers. This phrase is represented by using this symbol R with a line through it. And of course, the range, we look at the graph and we determine the minimum value. Tells the range of the relation. There are many other ways to write domain and range. If you want, you can write it as words like this. You can say y is greater than or equal to -2. And that's also a fine way to represent the range. But of course, if you use the symbols and if you know how to use the symbols, your writing will be more efficient. So let's just go through the key vocabulary here. The continuous data is a data that can take any value within the range. It is usually measured. So examples are time, height, temperature. And the discrete data is the data that can only take specific separate values where we count. The number of people, number of cars is the examples of the discrete data. Domain and range, as we said, is a set of all possible x values and the y values, or in other words, the domain is a set of all possible independent values for the independent variable, and the range is a set of all values for the dependent variable. Thank you for watching this video, and I'll see you in the next one.